Now you can message to the host because I'm the host, I guess. Okay, the question for today. Yeah, Kishan, I'm able to see your message as well. You have been given a parenthesis. Basically, you have been given n equals to, let's suppose 3. Okay. And you have to form like 3 pairs of parentheses you have to take, and you have to form the valid parentheses. Is this a valid parenthesis? You want to find out the set of subsets. Kishan, I didn't get your question. You want to find out the set of subsets. I understand the question. You want to find subsets of a set. Okay, all the subsets you want to find. Got it. Okay, got your question. Just understand this particular question. If not able to do this still, I will be telling you the solution tomorrow, but just understand this. In this particular question, every time we are including a number and we are excluding a number, right? Getting this? So same approach you can follow, and you can just remove the sum, like a little modification to this particular program, and you will be good to go. I hope you are getting me. Okay, you tried. So if possible, you can discuss your approach with me or share your code. I'll look into it and will tell you like what's going wrong in that. Okay, will that be fine?
Ma'am, I have one question, ma'am.
Yes.
Yes, same problem. Can you scroll left side?
Yeah, sure.
The execution, right? So how it will be recursion, right? The pipe symbol, right? I want to understood the execution, ma'am. So,
You want to understand its execution? Are you saying
yeah,
that?
yeah. See,
Okay.
first subset it will enter inside, right? So
Correct.
first inside subset it will execute. Another one after pipe symbol we have another subset, right? Parallel it will execute, or how is it?
No, it won't execute parallel. See, what is the meaning of recursion? Once it see this subset, obviously it know that it has to call the function again. Yeah, that's why the remaining function call, the function after the pipe symbol, goes into the recursive stack. Okay, that is in the pending zone. So once, as you saw, no, that we are returning the result, then we are calling the remaining functions, right?
Yeah.
That is from our recursive stack.
Okay, got it.
Clear?
Yeah. One more, previously we done Tower of Hanaya, right?
Yeah.
So there you told some conditions, ma'am, but while writing program, right, we didn't write any conditions, right?
Okay, I'll explain that once again. The condition in the Tower of
I mean,
Hanoi
smaller,
was.
yeah, smaller.
See, we know that like we are following our approach of like shifting the biggest one to the destination tower, right?
Yes.
So if we know at the at the first step that we are doing that, as I told you, that if we have to move 3, then we have to move n-1 disk to the B tower, right?
Yes.
So from the very first step, we have made that assumption that every time our disk are going to be in their proper places. That's why we have not kept the check for that.
Can you repeat me once again?
What I'm saying is, in the starting only, we have made the assumption that we are always moving the biggest disk first, and then we are like keeping the smaller disk over that. Okay, that is our assumption in the particular question. That's why we are not actually specifying any condition for this particular condition. Clear?
Okay. Yeah, clear.
Yeah. And moving one disk at a time, I hope you can recognize that from here, the printing statement only, because we are moving n-1 disk at a time, and then we are moving the nth disk from the source to destination. So I hope you can understand that we are only moving one disk at a time. Yes.
Yeah. Yes.
Yeah. Any other doubts?
This one, ma'am, 1 second. So second step, right? Bigger, 1 second. Can you repeat left side? Can you scroll? Yeah, you cannot put a bigger disk over a small one, right?
Correct.
See this one, how can we see, I mean, a bigger one, that condition where we are checking this program?
We are not checking that condition in this particular program, but what we are doing is, as I explained all the steps to you all, you clearly saw that we are first moving the smaller disk, right?
Yes.
And then we are shifting the bigger disk, right?
Yes.
So according to our assumption and explanation of the program, it was clearly understood that we are not moving the bigger disk at all over the smaller one.
Okay.
Clear? Because see, first we discussed and then we framed our solution.
Yes.
So we only keep the conditions for those things which we feel like, okay, it is necessary, but here it was not necessary. That's why we removed it. Clear?
Okay. Yeah.
Any other doubts or questions?
No.
The pipe symbol means calling first function after that. No, pipe symbol indicates the or condition. Or condition means either your first function is returning true or the second condition, second function call is returning true. Any one of it is returning true, then your answer will be true. Clear? Pipe symbol does not indicate that you need to call first function first and then the second function after that. Clear? And please do share your code of finding the subsets. I'll look into it. You can share it right away. And let's look into our current question now. So I was saying, if you have been given n equals to 3, it indicates the number of pair of parentheses. Yeah, it's fine. So 3 means you will be having 6 parentheses. And you have to form a valid parenthesis statement. So is this a valid parenthesis statement? Do they form valid parentheses or not? Yes. If I will form the parentheses like is this a valid parenthesis? No. So for n equals to 3, there will be so many valid parentheses permutation or combination, right? Can you all tell me those valid permutations for n equals to 3? You can also try to find out for n equals to 2. That is total number of brackets will be 4. Okay, I got one more. That is okay. Just tell me for right now n equals to 3, then we will focus on n equals to 2. Yeah, got this. Good. I got 4. Okay, I got all of them. One is gonna be this. Clear to everyone? Will there be any other possibility? Kishan is saying, okay, yes. For n equals to 2, can you guys help me? Okay, first is this. Second is gonna be this. Any other possibility? No. So in this question, you will be given n. N can be any number. Okay, and according to that, you have to form, generate all the valid parentheses. Clear? You all have solved the problem in stack where you have to find out if the given parenthesis stack is like a valid stack or not. But in this particular program, you have to generate that stack. Clear? Okay. How can we do that? You have to analyze, first of all, these outputs, first of all. Can anyone tell me what are the common things in these two outputs that we need to follow in our answer? Yes, guys. Equal number of opening and closing bracket, that is obvious. So you always need to make sure, like let's suppose I'm opening brackets, I'm calling it as an open. Opening brackets should always be equals to, I will say n, and also closing brackets should also be equals to n. It should not exceed that. Okay. Any other observation? This is your first observation. Opening should be equals to closing if you want to have the valid parenthesis. Any other observation? Can you ever place a closing bracket in your particular stack set if you don't have an opening bracket? Can you place a closing bracket before opening bracket? Will it be valid? No. So you should always make sure that there is an opening bracket before the closing bracket, right? So to make sure that, you should be having a condition like that number of closed bracket as of now are less than the opening bracket. In the case, even if they are equal also, like let's suppose closing is equal open, in that case also you cannot insert a closing bracket, right? Because then it will exceed the closing bracket. Everyone, are you clear or not?
No, madam. If it will never be unequal, if it has to be like a balanced.
See, in the end, it will be automatically balanced, right? But I'm talking about the condition. Let's suppose you came inside your function call and like, let's suppose you're not putting an opening bracket and this condition is kept that closing should be less than open bracket. Then it will be ensured that you won't be having a closing bracket before the opening bracket.
Yeah, I got it. Yeah.
Clear? You will get it's more analysis when we will write the code for this. But as of now, these two conditions are fixed. Yes or no? Yes. Okay. So can you repeat the second? Second condition is, Aman, that can you ever place the parenthesis like first closing bracket, then opening bracket?
Yes, ma'am.
Can you place this?
No.
No, it's not valid, right?
Yes.
Yes. So for this case, we should always be sure of that our number of closing brackets should always be less than the opening brackets.
Can you show me with example in 1 to 5?
Yeah, I will show that with you an example. Let's suppose initially we kept, like, let's suppose I have kept the opening bracket. You all are very sure that our first bracket is going to be the opening bracket, right?
Yes.
Yeah. Now it will be having two conditions. Either it can have another opening bracket or it can have another closing bracket, right?
Right.
At every point, let's suppose I am placing the closing bracket over here.
Okay.
Okay. Now at this point, it will be having two options, either the opening one or the closing one.
Right.
Okay. Till now, your open count, like number of open brackets, is equals to 1. And closing bracket is also equals to 1. Okay. Now, can I go with the choice of closing bracket again here?
No.
Why?
Because in the second case, it is a closing bracket.
Because you only have one opening bracket, and as
Yeah.
per the rule says,
Right.
if you have number of opening brackets, then you have equal number of closing brackets. You cannot have closing bracket greater than the opening brackets, right?
Right.
Right. That's why it is invalid.
Yes.
So when we will check this condition, that closing should be less than opening, at this point it will fail because open is also one, closing is also one. This condition will fail. Hence, we will not take the closing bracket again.
Yeah.
And we will go with the opening bracket. Clear?
Right.
Everyone, if still you are unclear, we will see it in the demonstration of the code. Okay, no need to worry about that. So can we proceed towards the code? Anyone would like to participate? Don't worry, you need not think of anything. I'll help you out. Just you need to unmute yourself and help me with the code writing. Anyone who would like to participate? I'll give you 2 minutes of time to think yourself. No, not typing will work. I want someone who can unmute. Yes, guys, what happened? No one is ready to say anything. If no one goes, I'll go. Okay, Kishan, you can unmute if possible.
Yep.
Yep, okay. The first thing we need to figure out in recursion is the number of parameters. Okay, so can you help me with that?
Yep. We will be having the n value. That means how many
That
number of brackets we need to print n.
Correct.
Mhm.
You will be storing your entire pattern in some place, right?
Yes.
Yeah. For that,
We can have stack or
a character array. It will be better.
would be fine. Yeah.
Stack will also work, but character array as of now we can take. Any other thing?
Maybe something increase the value.
You should be having an index, right? So that you know like how much array you have filled till now.
Yes, int index.
Yeah. And as we spoke about it, we should be having the count of opening and closing brackets. So that too should come into consideration. Int open
Close.
and int close. Any other thing which is like necessary as of now? In
Seems
the parameter?
fine.
Seems fine.
Yeah.
Okay. Now can you tell me the first condition that we should go like so that our pattern at least start its making?
Yes.
Yeah.
Maybe we can see like our opening and close should be equal.
Not
That
equal.
would be the first. Close should be less than open, right?
Yeah, but first of all, how you will start your pattern will be that you should start with your opening bracket, right?
Yes.
And for that case, you should be having the condition as if open is less than n.
Open.
Because in this case, you know that if
Right.
open is less, what are you saying?
Right.
Right. Okay, if this is the case, then what you should do, you will
We will
append.
be inserting into the char array. Maybe
we will
calling the solve function with n value.
Correct. But we will first append the value in the character array. that is char of index is
Equal
equals to
to,
your
one-
opening bracket.
Yes.
After that, you need to call your, like, since you have now filled the one bracket, you need to call your solve function again for the remaining
Yes.
permutations.
Solve with n ch. IDX will be increased.
Solve, and n will be the same.
N ch IDX plus plus.
Yeah.
Then open will also be increased. And close will be remaining same.
Open will be +1 now,
Yes.
and
Open plus one.
close
and
will
close
remain
be
same.
Yeah.
Correct.
Ma'am, open can be equal to n.
Okay. And your thought behind that?
Our index will start with 0, right? So it
Correct.
should be less than n.
Okay. Yeah.
Got it, Aman?
Yes.
Yeah. Now, in the next condition, you need to take care of the closing brackets. What will be the condition for that?
We can have else if. Else if, yes. And there inside else if we will be checking
If
Uh,
will also work,
if
not
will
an
also.
issue. Yeah.
Okay. So we can check that the closing bracket condition, closing should be less than open.
Should be less than open. If this is the case, then again, we will repeat the same things. Just instead of opening bracket, it will be closing bracket.
Yes. And close plus plus instead of
Yeah.
open
Can you
plus.
tell me why I told you that if will be better than else if? And everyone in the class, can you tell me why we are not using else if here?
Yeah, I think that else if will only execute if has failed.
Correct.
But if we have two ifs, then both can execute.
Yeah. And
independently.
why we want both of them to execute? You're going right. Just tell me a little more
So after the
explanation.
yeah, so when it goes for the second time, the second open brace is there, open bracket is there, then it will go to the second if and execute. If it was else if, then it would have ignored the this second condition.
I'll explain you. Yeah, you are going right, Vishnu. Just a little more addition to it. I'll explain you.
IDX will be +1. Open should be normal and closing will be
Close.
+1. Yeah.
Correct. Guys, see, I'll strongly recommend you all to do this exercise more often with me in the class, like telling me the answers to all the questions, because these kind of interviews also happen. Okay, so this is gonna be a profit for you all only, not it's gonna help me. So yeah, make this as an habit for you. What will be the base condition where your loop should stop?
Open is equal to close or open is equal to n.
It works, but see, we are taking an array, right? And we know once it is filled, we need to print our permutation. So we can write here that your index.
Okay, index is equal to n.
Correct.
Okay.
You can write also like what you were saying, but this is a foolproof solution. So you can write this as well. And here you can write your conditions for printing your char array.
Array.
Clear, everyone?
Ma'am, can you explain
Why 2
CH of ID?
CH of?
ID?
CH of index. Yeah, I'll explain that. Yeah, anyone was saying any other doubt?
Like why 2 ifs?
Why 2 if? Yeah, I'll explain that. See, we know that once my calling for this function will be like, let's suppose I'm passing n as 3. My char array is empty completely. And index will start from 0. Our open is also 0 and close is also 0. This is how I'm calling my function. It will check the first if condition. If index is equal n. Is 0 equal 3? No,
Okay.
it's false. So it will go in this particular if condition as of now, and it will see if 0 is less than n. The condition is true, so it will enter here, and it will, like, this is your char array, let's suppose. and it filled the first character opening bracket. Now, you know that it is calling the solve function again. Obviously, it will go up now. Okay, it will go up here, increasing the value for open. Open value will now change here to 1. Again, it will check if index is equal n. That is 1 is 1 is equal 3. It's false. It will come again and see if 1 is less than 3. True again. It will enter here, add one more character to it, and then again it will make a call to solve function. Solve function will go up again, change the value for open to 2. Again, it will check if 2 is equal 3. False again. Now it will go and check here if, sorry, my bad. Index should not be equal n. It should be 2n. Because we need to fill the entire array.
Yes, yes.
And now when it will check that like 2 is less than 3, it's correct. So again, it will fill in one more opening bracket. Clear? This time when it will call the open, like this solve function again, the value for open will be now 3. And now it will again check if 3 is equal 2 into n, that is 6, which is false again. It will come here and see if open is less than n. Is it true or false?
False.
False, right? Why false? Oh, sorry. Yeah, it's false. Now, since it is false, what it will do? It will go to the else, like this if condition, and it will execute, right? It is working fine. Even if I would have kept here else if, it would have worked fine. So here comes similar way, 3 closing brackets. But now let's suppose this thing is executed. This particular permutation is printed. Okay. Now you would be having some permutations left before it. Like you are stacking up your permutations, right? When you took here one opening bracket, then you stacked this particular if condition, right? But if it would have been an else if condition, then obviously it would not care. It will be like, I have executed the if condition. There is no need to execute the else if condition. And hence you would have missed few of the permutations. Clear? And anyone who is like more curious, then what you can do here is you can put an else if condition over in your, like while executing this program, and see how many permutations you are getting. If you are getting all the permutations, then it's fine. But if it is missing it, then you should know that why it is missing. Clear? Because else if basic role is that it should execute either the if condition or the else if condition. But here we want that both of these conditions should be executed so that we can get all our permutations. I hope you all are clear. Okay, now I will quickly show you the diagrammatic representation of this particular program. You will get it in a more better way. You have an opening bracket in the first place that you know. After taking this opening bracket, as you all saw, we are again moving towards the one more opening bracket. And after this, one more. I'm taking the example of n equals to 3. After this, when it is trying to like run for the opening bracket, it won't, and hence it will go for closing bracket, one more closing bracket, and one more closing bracket. Does at any point there were chances of the opening bracket again in these 3 conditions? No. What it will do now, it will backtrack. After giving this result, it will backtrack to here and see if there are any function call remaining. No. Again, it will backtrack over here and see if there are any function call remaining. No again. It will move here and see if there any other possibility there. Is there any other possibility at this point? No. Again, it will backtrack on the second opening bracket. And is there any possibility here?
Yes.
Yes. So what it will do, it will go and now take, instead of the opening bracket, closing bracket. This is what I was talking about, the if condition. Now, after this closing bracket, you have again two options. You can either move towards taking one more opening bracket. Can you move towards taking one more closing bracket? Yes, but first it will move towards taking the opening bracket because it is the first function call. It will take the opening bracket. Now, after this, sorry. Yeah, after this, what it should take? Closing. And one more closing. Any other option left with it? No. Now, again, these will backtrack. Backtrack in the sense, every time it will see if any function call is remaining in the recursive stack. Nothing is remaining. It will go here. Nothing is remaining. It will go to here. Here it sees that there is a possibility of calling a closing bracket function. So it will call here a closing bracket. Now, after this, it has an option of calling an opening bracket. It cannot call a closing bracket here, right? Because you can see two open brackets, two closing brackets. It cannot take one more closing. So now it will take opening, and here it will take one more closing. After this, now again, these will backtrack. Is there any option left now? At this point, both the options are executed. So it will go in here now. With this, it will call now a closing bracket. After taking closing bracket, you have two options left. Sorry, two not, one only, opening bracket. So it will take an opening bracket. At the opening bracket, you have two options, either to take an opening bracket again. So I'll take that. Then after that, it will be having two closing. Either you can take this closing, then again an opening bracket, and then again a closing bracket. Clear, everyone? And this is how your result will be generated. If you all want, like I am keeping here the condition now, so don't keep the condition and try to generate all the possibilities of the invalid parentheses also, then you will get a better understanding. Anyone in the class who is still not getting this question? Yes, guys, you can say it. Let me just. Aman, did you got it? Aman, Ashish, Mohan.
Yes, ma'am.
Okay. Sai, Mani, Vipin, Vishnu. Okay, then. Try to execute this particular problem. I guess it is on the LeetCode. I'll share the link so you all can do it. Has anyone ever heard about the magic square problem? Yeah, it is there on the HackerRank as well. Okay, I'll just explain the problem today so that you all can have the time to brainstorm about solution for tomorrow, and then tomorrow we will discuss its solution. Okay, because okay, so you have been given a matrix of 3 by 3. It is a fixed thing. You cannot get ever a matrix which is like n by n. You may, but like we are solving it for a smaller scale. 3 by 3 matrix you have been given. The matrix question like values are 2, 8 and 5. Then you have been given 1, 3 and 7. And then next numbers are 4, 9 and 6. This is your matrix. The condition for a matrix to be a magic square is sum of all its rows, sum of all its columns, and sum of numbers in all, like in its diagonal, should be same. If I take the sum here, it will be like, I guess, yeah. So 2 plus 8 plus 5, it is 15. For the diagonal, if I'll see, it will be like 5 plus 6, it is 11. And for the column, if I'll see, I'll get here 7. They are not equal. And we have to make it as a magic square. That is, the sum of all its rows, columns, and diagonals should be equal. So that means you need to change the number in every cell. Clear? Like if it is required, you have to change it. If it is not required, then let it. Clear? Okay. Now, can anyone tell me a matrix which is a magic square? Like whose sum of row, column, and diagonals are equal? Think of it and tell me. I'm giving you 2 minutes of time. Okay, so Vishnu, what you want me to repeat?
So can it be like 111 or one digit can reoccur?
No. The numbers should be unique. It should be between 1 to 9 and they should be unique. They cannot repeat. We need to consider 3, 7, 9, 6. That also. See, what I'm saying in this particular question, every row sum, at any instance, I take any row sum, any column sum, or any diagonal sum, I should get equal value. So that means you need to take care of in throughout the matrix. It's not about the first column, first row, and first diagonal. Okay, I've got one permutation. Good job, Aman. Let's just check if it is correct or not.
276.
Yeah, I'll just make a matrix and then I'll write the values. It is 276
951 438.
438. If you will see it like the sum in the first row, 2 plus 7, 9, 9 plus 6, it's 15. Okay. I'll check the sum of other rows as well. 9 plus 5, 14 plus 1, 15. 4 plus 3, 7, 7 plus 8, 15. Okay, all the row sum is same. Let's go for the column. Column 11 plus 4, 15. 12 plus 3, 15. And 7 plus 8, 15. Column are also the same. 7 plus 8, 15. Then 11 plus 4, 15. Yeah, this is a magic square. Any other permutation can you get out of this? This is one permutation. Okay, I'll give you another one.
I'm actually not getting the question. Like if we take a 1,1 value, like 0, 1, 1, 1 and 2, 1, 7, 5, 3 sum.
Just a minute. What you are saying? 0, 1?
This one, 7, 5, 3.
7, 5,
In the
3.
second,
Okay.
in the
Yeah,
second
say.
square.
Then?
I wanted to ask, like, we need to start from 0, 0 or all the columns we need to check?
Basically what you need to do, you know that we can form several like permutations of these particular 9 values, right? Like let's suppose you have been given 3 values. Like I'll take 4 values as of now. 1, 2, 3 and 4. Okay, imagine it is your 2 by 2 matrix. I'm taking over here. Here it is 1, 2, 3 and 4. Other combination possible for this will be, you can take it as 1, 2, 4, 3. Okay. Looking at the other way around, what can we take? We can take here 1, 3, 2, 4. The other one we can take here was 1, 3, 4, 2. Like there can be several permutations for this particular 2 by 2 matrix, right? And amongst that permutation, you can add all the rows, like for checking whether it is a magic square or not. You try to add the number of all the rows, try to add the numbers in the columns, and try to add number in the diagonal, and see if for that particular permutation you are getting the sum equal. If you are getting the sum equal, then it is a magic square. That is your first condition. Okay, as of now I have not even told you what is the second condition. This is your first condition. Clear? So I hope your doubt is clear that
No,
like from
actually,
where you have to.
sum of first row and sum of first column, you mean, right?
Any row, you can take middle row as well.
So here in this case, the second matrix which you have taken, 7, 5, 12 is 15. Okay. And for this, what will be the column?
For what?
For the second column in the second matrix, 7, 5, 3, the sum is 15.
Correct.
How will be taking the row?
The row is 9, 5, 1, right?
Okay, so middle one will be taking.
No, I am just saying, let's suppose you got this permutation, okay? 2, 9, 4, 7, 5, 3, 6, 1, 8. Okay.
Okay.
Find sum of all the rows. Just what I did when like Aman told me. I find out the sum of all the rows. It was 15, right? Then what I did, I find out the sum for all the columns. They were also 15. Then I figured out the sum for all the diagonals. They were also 15. Then I said that, okay, this is a magic square. So you need not find any relation between rows and column. You can find the sum individually also. It's fine. Is it making any sense right now? Okay, fine. I'll give you another permutation for this as well. And why I am saying that only first row and first column are not sufficient, because let's suppose I interchange these two values. Then what will happen? Will it be a magic square anymore? No. But the first row and first column are having the same sum. But still, if we look towards the middle column and the middle row or last row, it won't be. And hence, we have to take the sum of all the rows and all the columns. Clear? Okay. This is another magic square. Can you all find out the sum for this? And tell me if it is a magic square or not. Like you can just cross verify it. Yes, it is. Okay. Yes. Yes, it is a magic square. Okay. Now our real question is, we are interchanging the values in every position. Let's suppose in the first cell it was 2 and here in the first cell it is 8. So basically whatever value we are changing, we have to take its absolute difference. Okay, that means 8 minus 2, you will be getting it as 6. For the second cell in the first row, it is 8 and here it is 3. If I'll subtract and get the absolute difference, I'll be getting it as 5. For the next, like the last cell in the first row, it is 5 and this one is 4. You will be getting the difference as 1. Clear? Taking for the next row, it will be 0. For the first cell in the next row, 3 and 5, you will be getting it as 2. 7 and 9, again 2. 4 and 6, 2 again. 9 and 7, 6 and 2, 4. What is the total of it? 11 plus 1, 12. 12 plus 2, 14, 16, 18, 20, 24. Same thing we will do for this particular magic square. We will be getting here 0, then 1, then 1 again. Plus we'll get here 8, then 2, then 6, 0, 6 again, and 2. What is the sum for this? 10 plus 12, 12 plus 6, 18, 18 plus 6, 26. So out of these two answers, the smaller one is this. Hence, we will take this as our answer as of now. Okay. The basic, like the funda of this particular question is, you need to find a magic square with which you are getting the least difference. Okay. With which you have to spend the least cost, because this is the cost you need to spend to make a normal 3x3 matrix into a magic square. Okay, and you are always like very curious to spend the money, hence you need to spend as little as possible. Clear?
Ma'am, how did you write 0 plus 1 plus 1?
See, I subtracted first cell of the original matrix with the first cell of your magic square and I got 0. Like 2 minus 2, 0. Then I subtracted 8, that is the second cell of the original matrix, with 7, which is the second cell of the magic square, and I got 1. Clear? Similarly, I did with all the cells of the matrix. Aman, is it clear now?
Yes, ma'am.
Okay. Guys, did you understood the complete question now?
One question.
Yes.
In original matrix, we are in the second row, we are having a value 1. In the other matrix, we are having a value as 9. So we'll be, after subtraction, we will be taking the value of like mod.
Yeah, I told na absolute difference. Absolute means you need not consider the negative value.
Okay.
Question is clear to everyone? Okay, so that is your task, and yeah, you can find the answer for this, or like at least any observation you can get by tomorrow, and if not, then we will be discussing the solution for this. Clear, everyone? Okay. This is a very interesting solution. So try to look into this. And yeah, we will be discussing the solution for this tomorrow. I guess it is the main milestone for recursion in our particular course. Then I guess we are having 2 more questions for the recursion and backtracking. And after that, we are done with recursion. Clear to all?
Yes, ma'am.
Okay. Anyone feeling we have solved very less questions in the recursion and you want more practice? Because recursion topic is just about understanding the way we are solving it. So I have given you variety of questions to understand that. If you are still feeling like that, then you can tell me. I'll add few more questions to it. No issues. Easy questions. Okay. More suggestions from LeetCode or HackerRank would be fine. Okay. For homework will be given to you. Have you solved the stack questions? First, answer this. Okay, Kishan has solved. Kishan, I'll send the Q questions today. No. So Vishnu, do that. Solving recursion. Yeah, Aman, that's good that you're solving recursion. But if I've given you the questions for stack, then do that also. Okay. Yeah, I'll be sharing the questions for recursion as well. And queues. Okay, then I'll stop the class for today here. And we will be discussing more questions tomorrow. That's it. Thank you all for joining the class today. We will meet tomorrow. Bye-bye.